All right, welcome. And today we're solving valid anagrams. So let's dive into the problem. It says we're given two strings S and T, and we need to determine if they are anagrams of each other. So what is an anagram? It means that both strings contain the exact same characters and the exact same frequency. So just potentially in different orders. So example, race car and car race, or Hannah and Hannah, are anagrams since they both contain the same letters, but like jam and jar would not be anagrams since the characters don't match. A brute force approach would be to sort both strings and compare them, but that would be pretty expensive to do, so we're not going to do that. Our approach will be to keep track of how many times each character appears, and since the problem tells us that the strings only contain lowercase English letters, we'll use a fixed size array size of 26. Why 26? There's 26 letters in the English alphabet for your information. Index 0 represents A and index 1 represents B, and so on and so forth. And as we're looping through both strings, we'll increment counts for characters in S and decrement counts in characters T. And if the strings are both valid anagrams, every value should end up back at 0. So it's time to implement the solution. So we'll begin with the first optimization, and what we'll be doing is comparing the length of strings against one another. And if they don't have the same length, we can immediately rule it out that they can't be anagrams, so we'll return false. Then we'll create a array of 26 zeros, and this is what we'll store our character frequencies. Now we'll loop through both of these strings at the same time, and then for the character in S, we'll convert the character into an index using ASCII values and then increment that count. And then we'll do the exact same thing for characters in T, but this time instead of incrementing, we'll be decrementing. And then lastly, if every one of our values ends up 0, this means that it canceled out and the strings are valid anagrams. Otherwise, they would not be. And this gives us a solution that is O of n time complexity and O of 1 space complexity. So if you enjoyed, like and follow for more.